We've all heard about doomsday scenarios. Nuclear war, giant asteroid strikes, supervolcanoes, things that could wipe out life as we know it. But what about Earth itself? Not just scorching the surface, but actually shattering the entire planet? Is that even possible? Well, the physics of breaking anything, including planets, is pretty simple. You just have to add enough energy to overcome the forces holding it together. For Earth, that force is gravity. It's the glue generated by nearly 6 septillion kilograms of rock, metal, and molten chaos. So, how much energy would it take to tear the planet apart, to overcome that immense gravity and send the pieces flying off into space? Brace yourself. It's about as much energy as the Earth receives from the Sun over 40 million years. That's a mind-boggling number. Okay, maybe you don't want to completely obliterate it. What if you just want to crack it in half, like a cosmic egg? Great news, it's discount time. For that, you'd only need the equivalent of 16 million years of sunlight. Still utterly ridiculous, but hey, it's technically less ridiculous. So let us ask the big question. Could anything in the universe realistically deliver that kind of planet-shattering punch? Let's start with our own toys of destruction, nuclear weapons. Could we just nuke the Earth until it vaporizes? The most powerful bomb ever detonated was the Soviet Union's Tsar Bomba, which packed a punch of about 50 megatons of TNT. That single explosion flattened almost everything within a 20-mile radius and shattered windows hundreds of miles away in Finland. A terrifying weapon, but to blow up the entire planet, you would need over 1 quadrillion of them. 1 quadrillion Tsar Bombas. There isn't enough uranium on the entire planet to build that many. And humans definitely don't have the time, resources, or collective sanity to construct a quadrillion of anything, let alone city-destroying superweapons. So, verdict? We could certainly nuke ourselves back to the Stone Age and turn Earth into a dead, radioactive rock, but we can't blow it into pieces. So what's the next option? Let's look to the skies. What about asteroids? The asteroid that wiped out the dinosaurs was an absolute monster. It hit with the force of about 1 million Tsar Bombas. It was a global catastrophe, an extinction-level event. And yet, that impact delivered only 1/billionth of the energy needed to destroy Earth. Let that sink in. A planet killer for life, but just a pinprick for the planet itself. Even if we took 4 Vesta, one of the largest asteroids in the entire solar system, and slammed it into Earth, it would still only deliver about 0.5% of the required energy. The problem isn't just size, it's speed. Kinetic energy depends on mass and velocity squared, so speed is a huge factor. To shatter Earth, an asteroid would need to hit us at about 700 kilometers per second. That's fast enough to travel from New York to Los Angeles in under 5 seconds. Asteroids in our solar system simply don't move anywhere near that fast. But you know what does? Other planets. So, could Earth collide with another planet, say Mars? Now, this sounds like pure science fiction. Mars has a stable orbit well outside of our own. But the solar system is a more chaotic place than it looks. Every planet, moon, and asteroid exerts tiny gravitational nudges on everything else. Most of the time, these little tugs cancel each other out and nothing dramatic happens. But over billions of years, these tiny effects can accumulate in unpredictable ways. In one fascinating set of super detailed simulations, physicists decided to test this chaos. They tweaked Mercury's starting position by just 1 single meter and then let the solar system evolve for billions of years on a supercomputer. In about 1% of those simulations, the planetary orbits went haywire. They stretched and warped, becoming highly elliptical. Earth started doing cosmic drive-bys past Venus and Mars. And in one of those simulated futures, Earth and Mars actually collided. Hard. The impact would have been catastrophic, likely enough to severely damage both worlds, if not completely obliterate them. Now, is this likely to happen? Not really. The odds are incredibly low, but it's not zero. It's one of those chaotic but technically possible endings for our world. But there's another fate for Earth that isn't just possible, it's practically guaranteed. Let's talk about the Sun. Our star isn't going to shine forever. In about 5 billion years, it will run out of hydrogen fuel in its core and begin to swell into a red giant. It will become so enormous that its outer layers will expand beyond Earth's current orbit. If Earth were to stay exactly where it is, the Sun would simply swallow it whole, slow cooking the planet until it completely evaporates. But there's a twist. As the Sun expands, it will also lose a significant amount of its mass. This will weaken its gravitational pull, causing Earth's orbit to slowly spiral outward. For decades, astronomers debated this cosmic race. Would Earth drift away to safety, or would it get roasted? Recent, more detailed simulations have given us a likely answer. It seems Earth's outward drift won't be quite fast enough. The planet will end up just inside the sun's expanding outer atmosphere. The drag from the hot solar gases will slow it down, causing its orbit to decay until it plunges into the star. Goodbye continents, oceans, and mantle. All that would be left is a cloud of iron vapor mingling with the dying sun. Now for the most dramatic, most cinematic ending of all, the Big Rip. This one comes from the strange nature of the universe itself. Right now, we know the universe is expanding, and that expansion is accelerating. The culprit is a mysterious force or substance we call dark energy. For the most part, this expansion happens in the vast, empty spaces between galaxies. But what if it got stronger? Some cosmological models, which are consistent with our current measurements, allow for a scenario called the Big Rip. In this future, the expansion of space doesn't just accelerate, it runs completely wild. The repulsive force of dark energy would become so powerful it would start to overcome all other forces. First, the space between galaxies would stretch so fast that they would disappear from each other's view. Then, the force would become strong enough to overcome the gravity holding individual galaxies together, and they would break apart. Next, it would tear apart solar systems, flinging planets away from their stars. Then it would get personal. The force would overcome the chemical bonds holding molecules together, and then the electromagnetic forces holding atoms together. Then, finally, it would rip apart the protons and neutrons inside the atomic nucleus. Everything in the universe, literally everything, would be torn to shreds by the stretching fabric of space-time itself. Is this guaranteed? Absolutely not. Many physicists are skeptical, but technically, the data allows for it. And if it happens, being shredded by the very fabric of reality is one heck of an exit. So, when we look at all these potential endings, from our own failed attempts with nukes to rogue planets, a hungry sun, and the entire universe tearing itself apart, what is Earth's most likely fate? The slow, inevitable roast as our sun grows old and turns the inner solar system into a cosmic furnace seems to be the odds-on favorite. But the universe is a big place, and there's always room for surprises. Which of these endings do you think is the most epic? And are there any other Earth-destroying scenarios you can think of? Let us know in the comments, and thanks for watching.